Hi guys, I just want to go over a little Simpsons math here and also talk about different bases. So we work on base 10. So our digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so sometimes we start at 1 and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and we say our 10th digit is 10, but not really. What 10 is it takes two of our digits. It takes the numbers 1 and 0 and puts them together and gives us the next number, the next sequence of numbers. We go all the way to all the tens, all the way to 99, add another 0, and we're at the hundreds, et cetera, et cetera, et cetera. So we know how that works, right? So that is great, and this is called base 10. And you might get a little freaked out what we're going to do about what we're going to do right now. But if I said something to you and I said to you, "What's 3 times 3?" 2, you would say 6, right? If I said, "What's 3 times 4?" you'd come back and say 12. And if I ask you why that's the case, you're going to go, because that's what it is. But the truth is, it's not what it is. It's what you've taught yourself. And the reason this works is because we use these 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the question I have is, why do we have 10 digits? And if you say, well, that's what we have, well, that is true. That's what we have, but why? And then someone might come back and say, because that's how we were taught. And I say, okay, but why? Why 10 digits? What is special about 10? And the truth is nothing special about 10, except there's a reason we use 10. And all you have to do is hold up your hands and say, we use 10 digits because we have 10 digits, right? 10 fingers. So count your fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? Don't forget 0 is kind of hidden in there. So those are our 10 digits, and these are our 10 numbers that we use to work off this. Now, that's great. But now let's talk about The Simpsons a little bit. Okay, so The Simpsons, you guys know, I'm sure you've been watching for years. And the person I really want to talk about is this girl right here, Lisa. Oh, I don't know what just happened to my pen, but that's Lisa. Okay, I just circled her. And if the question that we have is, how old is Lisa? That's the question that I'm going to ask you. And if we go ahead and we look it up somewhere, so I did look that up earlier. So let me see if I can figure this out. Let's go here. How old is Lisa? Oh, get out of here, please. How old is Lisa Simpson? Lisa Kudrow? No, Lisa Simpson. She's 8. So if you believe The Simpsons, she is 8 years old. But she's not. She can't be. And the reason she can't be is because if we look over here, The Simpsons shouldn't have 10 digits. Well, they should have some of these. Maybe I got a little excited right there. But The Simpsons shouldn't have 10 digits. They only have 8 fingers, so they should only have 7 digits. Sorry, 7 different numbers. And then after they go 1, 2, 3, 4, 5, 6, 7, their next number is the number 10, right? Because their 8th digit is 0. So think about that for a second. If you count your hand, your fingers on your hand, you go 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th finger is not 0. It's a combination of our 2 of our digits. So same thing will happen with these guys. 0, 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. So if here we have our numbers under, we can kind of correspond these with here. Their 10 is our 8, their 11 is our 9, and their 12 is our 10. Okay, think about that. There's no 8 or no 9 because there are no 9th and 10th digits on their hands. Stop and think. Think about that. We stop at 9. If another planet was looking at us and was teaching the same sort of math right now, they might say, oh, we have the same numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and they might have Schnurf and Lurf or something like that, and that's like our 10th and our 11th numbers here, okay? And they might just count like that, and then after Schnurf and Lurf, they might go to 10, right? So this would be base 12. But let's get back to the Simpsons. They're base 8. So base 8 is 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. And if you go, well, wait a second, how does that change the thing? Well, it wouldn't change this question because 3 times 2 is equal to 6. That's still the same thing. 1, 2, 3, 4, 5, 6 is still 6. But if I had 3 times 4, so if I had 3 groups of 4, and I said to you, what is that equal to? Well, let's count these in Simpson's world. It's not 12. Guess what? You can think of what it is, but let's count 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14. So 3 times 4 is 14. And if you had 8 fingers, if we lived in a world, the Simpsons were truthful, and we lived in their world, and they didn't have 8 and 9 as their digits, you would say 3 times 4 is 14, and you would say it as quickly as you would say 3 times 4 is 12. Is that nuts? Right? So if I said, what's 6 plus 3, you would say 11. Here's one for you. What's 11 minus 2? Think about that one for a second. 7? I think that's right. Okay. So if you say to yourself, that's all crazy and doesn't make any sense, well, it does kind of make sense. We already use a different base, and we use that with time. So if I said to you right now, we've trained our brains to work on base 12. So if I said to you right now, you're going somewhere and you're going from no, let's not use 11. Let's use, say, 9 until 2. Immediately your brain's going to go 9, 10, 11, or sorry, 9, 10, 1, 2. And in your brain, you're going to say 9 and 2, that's 3 hours, right? But you've trained your brain not to do that. And you said from 9 to 2 is 5 hours. But you probably take a little break before you do that. Because you think of 9 and you think of 12 kind of, right? Because the 2 goes usually with a 1 in front of it. And you go from 9 to 10, and then in base 10, you would go to 11, 12, and your brain defaults to 3. But because you've trained yourself with the clock that it's base 12, you know 9 to 2 is 5 hours, all right? So the math of that's kind of nuts. If you want to go crazy, you can start trying to learn that stuff, okay? And try to do math with base 4, base 3, or base whatever. The most simple base, besides 10, okay? Now 10 is simple, but it's simple because we've taught ourselves that, is base 2, which is binary. So binary goes 0, 1, and then after 1, they only have the 2 numbers, 0 and 1, and the next number is 10. And then 11, or 1, 1, they don't call it that. And then after that, you would then have to carry to 2, like this. And then, oh, no, what am I talking about? You would have to go to this, my mistake, right? I'm not too good at binary, I'll admit. And then here, you're going to carry that 1 over, I think, okay? And then you can keep going and going and going and going and going. And you're already carrying and using the 0 a lot quicker than you would with base 10. All right, so this is a little bit of base 8, base 10, base 2, and all that stuff. And the last thing I'm going to leave you is this. This guy right here. What is this? Can you guess what I'm drawing? If you're on The Simpsons and you see this animal, what do you call it? Not an octopus, but a decapus. And I'll leave you with this. Here's a picture of me fishing over here. That's me, my son, years ago. And that's the octopus that I caught with a ham and cheese sandwich as bait. All right, take it easy.